Today we're looking at translations on the coordinate grid or the coordinate plane. We have been talking about transformations. Translations is one of the transformations that takes place. And so let's take a look at some of the notes regarding translations. First of all, a translation moves every point of a figure the same direction. Let me change colors. And the same distance. That's the way it preserves congruency. It has to be the same size and same shape. The only transformation that does not maintain congruency is the dilation. So in order to maintain congruency here, it has to go the same direction. Every point has to go the same direction, the same distance. A translation can move a figure left or right, and up or down. Translations are also thought of as slides. Slides was one of the words that was used as a kind of a signal word for this type of transformation. Now, the next part tells us to translate the figure as described and use A through C to look for patterns in the ordered pairs. So let's look at what we're supposed to do. We are going 5 units left, 2 units down. I want you to keep in mind on the coordinate plane, when you're going to the right, and that's on the X, so this is X plus, this is X minus, or minus X and plus X. So if you go to the right, you're going positive. Go to the left, you're going negative. Okay, so on the y-axis, this is y minus, this is y plus. So down is minus, up is plus. So that's how we need to look at these movements. So it tells us to go 5 units left, 2 units down. So I'm going to mark my movement to get to my image from my pre-image. So 5 units left, 1, 2, 3, 4, 5. And then we're going 2 units down, 1, 2. So our first prime point is right there. Okay, that's A prime. So from the pre-image A to the image of A, that's from A to A prime. All right, so B, we're going to do the same thing. 5 units left. 1, 2, 3, 4, 5. 2 down. 1, 2. So our B prime is there. And then we look at our C. So 1, 2, 3, 4, 5. Remember, 5 left is minus 5. And then down 2. So this is C prime. Okay, so when we join those back together, I don't draw the straightest lines, but you can kind of see it is the same size, same shape. All right, let's record the vertices. So A was at 2, 4. And the prime coordinates, A prime is at -3, +2. And you can see that in the movement. On the original A, it was at 2 on the X, +4 on the Y. After the translation, it was -3 on the X and +2 on the Y. Now, for the B pre-image, it was at 6, 7. And for the B prime, it went to 1, 5. 1 on the X, 5 on the Y. The C pre-image was at 7, 3. The C prime is at 2, 1. All right, so that's how the pre-image is affected by the movement to make the new image. So describe how the transformation affected the X and Y values of each vertex. Vertex, remember, is just simply the corner. It's where the two segments come together. All right, so on the X values, they decreased by 5 or -5, and the Y values decreased by 2 or -2. Now, the way we summarize the effect algebraically is our X and Y coordinate transforms, and we use the little arrow, to X -5, Y -2. Okay, let's look at the next translation. So this one tells us that we need to go 4 units right, 3 units up. So remember that right is positive, up is positive. All right, so we're going right 4, up 3. So let's take a look at our pre-image point D, right 4, 1, 2, 3, 4, and then up 3, 1, 2, 3. So that'll be our new D, or as we say it, D prime. Now for E, right 4, 1, 2, 3, 4, and then up 3, 1, 2, 3. So that's where our E prime will be. Now F, right 4, 1, 2, 3, 4, up 3, 1, 2, 3. So we've got our F prime. So let's take a look at how that comes together. So you can see in this that it turns out to be the same shape, same size. So it is maintaining congruency. Let's take a look at the table. Then our image, our pre-image, D, was at -7, -4. Our D prime is -3, -1. Let's confirm that. So pre-image, -7, -4. So D, -7 on the X, -4 on the Y. Okay, so we're good there with those coordinates. Now the D prime should be at -3 on the X, -1 on the Y, and it is. So we're good there. So our E pre-image point was at -4, +1. Our E prime is at 0 on the X, 4 on the Y. Pre-image F is at -3 on the X, -5 on the Y. And then our F prime is at +1, -2. +1 on the X, -2 on the Y. So, now describing the transformation or how the transformation affected the X and Y values of each of the vertices, we have, first of all, X was increased. Four. So that's +4. Our Y was increased 3, so plus 3. How could you summarize the effect of the transformation algebraically? So remember our x and y coordinates. Transform to x plus 4, y plus 3. Now, on the next part of the notes for the translations or transformation translation, use the transformation of GHIJ to answer A through C. Give a verbal description of the translation. Okay? So we're going to take a look at what that translation looks like. Remember that this is the pre-image and this is the image. And we know that because this image has the tick marks or the apostrophes, which indicate the prime points, which means the translated points. All right, so let's take a look at the movement. So GHIJ, so we're going to start with G, or we'll just look at G to see where it moves, and everything else should move the same amount in order to preserve congruency. So we got 1, 2, 3, 4, 5, 6, 7 units left. All right, so minus 7, and then up 1, 2, 3, 4. So here's the description of our movement. 7 units left and 4 units up. Okay. Now, how would you represent the translation algebraically? So we have our x and our y coordinates, and they transform to x minus 7, y plus 4. So what do you notice about the line segments and angle measures in the pre-image and the image? The line segments and the angle measures in the pre-image and image are congruent. So we can just say they are congruent. So if they're not congruent, then if we didn't preserve congruency, then we didn't move it correctly. So that's how we know that they are the same shape, same size. Now, the coordinates for triangle KLM are given in the table. Eric plans to translate the triangle 9 units right, 9 units down. So describe how you could find the coordinates for the image. So you're going to add 9 to each x. Value. And then subtract 9 from each y value. Now it tells us to record the coordinates for KLM, those are prime, in the table. So our K, when we add 9 to the X, would be at 2, and take away 9 from the Y, or go 9 down from the original Y coordinate, would be -7. Our L, that's prime, our L prime is going to be at +7, -7. M prime will be at +7, -2. In numbers 5 through 7, the coordinates of a pre-image and its image after a translation are given. Use the points to give a verbal description and an algebraic representation of the translation. So what we've got, first of all, in the verbal of number 5 is 13 left and 7 up. So algebraically, x minus 13, y plus 7. For number 6, our x coordinate's going 1 right and 10 up. So x plus 1, y plus 10. Next we have number 7, which goes 6 left, 7 down. So x minus 6, y minus 7. So looking at the last part, the graph shows the translation of triangle ABC. Mark each statement as true or false and correct any false statement. So first of all, we have the triangle was translated from quadrant 2 to quadrant 4. Now let's take a look at that. This says it was translated from quadrant 2 to quadrant 4. Well, we know these have the tick marks, and so that has to be the image, not the pre-image. All right, so A is false because it's just reverse of that. It was translated from quadrant 4 to quadrant 2. B says the translation can be represented by x plus 10, y minus 10. All right, x plus 10, y minus 10. That is false. Let's take a look. If you deal with A, you see it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's x minus 10, and then goes up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's minus 10 plus 10, not plus 10 minus 10. So it's right the opposite. And then the last one, the translation preserved congruence and orientation of both the figure and the vertices. That is true, or it would not be a translation.